Right, good afternoon, everybody, and thank you for joining today's NARUC-DOE Nuclear Energy Partnership webinar on compensating nuclear energy. And I'm sorry for the background noise there. Before we get started, I would like to welcome our moderators for today's webinar. We have Partnership Co-Chair and Maryland Commissioner Anthony O'Donnell and New Jersey Commissioner Mary Ann Holden. Switch slides. All right, and I'll let them take it away with an intro.
Thank you, Jasmine, and thank you to Jasmine and Kira Zittelman for the fine work they do in helping us establish these. Thank you to everybody for joining our third DOE NARUC Nuclear Energy Partnership webinar. As co-chair of the partnership, along with Commissioner Tim Eccles of Georgia, I'm pleased to welcome everyone to this discussion on compensating nuclear power. Today's webinar will be recorded with the recording and slides posted on NARUC's website and emailed to attendees next week. In March of 2021, NARUC formally launched the 5-year nuclear energy partnership with support from the DOE Office of Nuclear Energy. Through this educational initiative, NARUC provides opportunities for state, public service commissioners, and commission staff to better understand barriers and possibilities related to the U.S. nuclear fleet, the nation's largest source of non-carbon power. We thank the DOE Office of Nuclear Energy for their continuing support. It's now my pleasure to turn the programming over to Commissioner Mary Ann Holden of the great state of New Jersey, who is going to lead us with speaker introductions and the bulk of the questioning. Commissioner Holden.
Great, thank you, Tony. And it's nice to be part of this third webinar. We have a terrific lineup of panelists today. I'll start with their introductions in the order in which they will speak. First, we have Dr. David Gaddy. He is an associate professor at the University of Georgia College of Engineering. Dr. Gaddy's research is focused on comprehensive energy policy and integrated resource planning in the electric power sector. He is a residence fellow in UGA's Center for International Trade and Security, where he engages in collaborative research on energy security and the national security implications of nuclear power. Dr. Gaddy also leads UGA's solar tracking demonstration project. Next up will be Steve Swilley. Mr. Swilley is a senior director and deputy chief nuclear officer at the Electric Power Research Institute, affectionately known as EPRI. He is responsible for administrative and technical direction for the materials, plant support, and innovation departments. These departments conduct research on materials issues, NDE, welding, long-term operations, flexible operations, non-destructive evaluation, plant modernization, AI, data analytics, and advanced nuclear technology. Before joining EPRI in 2003, Mr. Swilley worked at TXU in various engineering roles, supporting the Comanche Peak units during construction and operation. Mr. Swilley received a bachelor's degree in mechanical engineering from the University of Arkansas. And last but not least, Lori Bird. Lori Bird is director of the U.S. Energy Program and the Polsky Chair for Renewable Energy at the World Resources Institute. In this role, she leads a team of about a dozen specialists who work with utilities, cities, and other large energy users to decarbonize the electric sector and accelerate transportation electrification. Prior to joining WRI, she served as a principal analyst in the Markets and Policy Group of the National Renewable Energy Laboratory, NREL, where she worked on clean energy policy, renewable energy grid integration, solar programs for low-income customers, and green power markets. Over her career, she has co-authored nearly 150 publications on clean energy, including articles in academic and trade journals. She holds a master's degree in environmental studies from Yale University's School of the Environment and a BA in economics and environmental studies from Indiana University. She lives in a home featuring solar panels and passive solar design with her husband and 2 children in Boulder, Colorado, and has owned an electric vehicle since 2015. And now, Dr. Swilly? Dr. Gaddy, I'm sorry, I just promoted Mr. Swilly. Dr. Gaddy.
So if I could confirm, Jasmine, can you see that screen there, my title slide?
I think you need to switch. It's on the presenter mode, so you may need to switch this, but that should work.
There. Can you see that now?
I think it's still loading, at least for me.
Okay, let me stop. Let me go back. Maybe it's just a little sluggish. I'm not sure. I'm hitting the slide. Can you see it?
I can see the PowerPoint. It's not in presenter mode, but I can see your slides.
Okay. Yeah. I had it in presenter mode. So how about now?
Give it one moment. I do not think that worked, but we can see your slides.
Okay. I'm gonna go ahead with that then, yeah, because I'm seeing it. How about, can you see it changing slides there?
Yes, we can see it changing.
Okay.
It's still in the presenter mode with like the black background, but we can see it. And when you click the display switch, that does not change anything.
So if I go to the swap presenter view and slideshow,
Yes.
Yeah. We're good?
There we go. That worked.
There. Okay. I did that a while ago. Maybe it's just a little sluggish. I apologize. Maybe it's slow. So thank you, Mariana, for the introduction, and I appreciate y'all inviting me here. I guess I see now from Tony's introduction that he's in cahoots with Tim Eccles down here in Georgia. So I'm assuming now I know how my name popped up there. So thank you for having me. I'm going to take a little bit of a broader perspective here in this talk about U.S. nuclear power. And you can see here, I really want to look at this from an industrial base and national security perspective. And I do look forward to the conversation and questions after this. So a couple of contention points up front, two in particular. One is, while I can say this about energy in general, certainly it's about nuclear in particular, that it has intrinsic national security value. A point here for this presentation is that that value currently is non-monetized and it's not accounted for in our U.S. policy. I think that's a shortcoming. Secondly, again, energy in general, nuclear in particular, these aren't just market commodities. And again, central to the point I'm going to talk about today, these are central to the strength and diversity of our industrial base, which translates to our capacity to actually remain a great power competitor and protect our interests at home and abroad. So the U.S. industrial base, historically, you think about it, oftentimes it goes back perhaps maybe to the days of Eisenhower when you think about the defense industrial base. But great power competition in the 21st century has extended that field of competition, and now it includes energy, both the resources, energy resources, and those energy technologies as instruments of national power. This is something that the U.S. has not necessarily been up against in hundreds of years. This is a new field of play now, particularly as it pertains to China. A couple of quotes that I like to give. This is from John Allen, president of Brookings Institute. He had a great article in Shaping a Multi-Conceptual World back last year. And his point was, in particular about China, that it's moved into a new phase of expansion, and it consists of a global network of ports, technology plays, and infrastructure assets. And this is, of course, the BRI, President Xi's BRI, but John Allen's point of contention here is it's purposefully designed to challenge the West. Out of the Ronald Reagan Institute a couple of years ago was a really nice report about the contest for innovation, and it revolves around strengthening our national security innovation base. no need to read this entire quote, but the point here is we've got a long-term competition with revisionist powers, and it does revolve around a contest for technological superiority. Their contention here, of course, is that it's around those national innovation bases, and the national security hinges on the outcomes of that competition. So in that context, as far as U.S. global competitiveness, I want to just offer just a few slides, a few graphs here with regard to energy consumption, and I want to transition then into how that, when we look at global energy consumption in relative to not only the U.S., but also particularly with our great power competitors, Russia and China. So no real surprise here. This is essentially where we've been and where we're headed. We're at about 84% fossil fuels, and you can see here, for the most part, oil and natural gas are increasing. Coal does what it does from time to time, increases, plateaus. In our zero carbon resources down here, solar and wind are the ones carrying most of the non-hydro. Nuclear is generally flat down here, but 84% fossil fuels is a heavy lift if we're looking at a low or zero carbon future somewhere out in the 2040s or 50s. Of particular interest is if we look at the Asia Pacific region, where about 44% of global energy consumption is, and over half of the global population and more than a third of the global GDP. These are key areas, not only for economic growth, but as far as population growth, energy demand increases, and also very geopolitically strategic with regard to U.S. interests. Now, if we take that energy consumption and kind of break it down just a little bit more into fossil fuels, and then again, this starts getting to my primary point. We see here China, India, and the rest of the Asia Pacific countries. I've only taken out China and India. The one thing I want to point out here is that the U.S. is generally flat, advanced economy. We've been around a while. We've had time to develop lots of efficiencies here. But those Asia Pacific regions where there is significant growth economically and energy demand wise, going in just a little bit of a different direction than the U.S. is. Now, Russia in particular, you don't need me to tell you exactly what's going on, particularly right now over in Europe, as far as how Russia is weaponizing its oil and natural gas. They are an energy producer. 35% of their economy is hinged to oil and gas production. 40% of the gas piped into Europe is Russian. 17.1% of LNG is Russian. They, of course, have the Power Siberia natural gas pipeline to China. It's a 30-year agreement, and they're looking at feasibility studies for a Power Siberia 2. China, on the consumer end, they're a strategic challenger. They consume about 24% of the world energy, 43% of fossil fuels, something I'll get into in just a little bit. There are two primary policies here, the Made in China 2025, and then their 14th five-year plan includes all energy resources and technologies. And this includes fossil fuels and nuclear. They have their own Arctic policy. Even though they're not an Arctic member, they still are promoting technology innovation up there for oil and gas drilling and further exploitation, just like Russia is as well. Their Made in China 2025 policy, it's their state-led industrial policy. It's a whole of society policy of military and civil fusion, where their state-owned enterprises receive extensive financial assistance. And again, this is background to where I want to go with the nuclear part. And so this is where we've been. This is a comparison of the U.S., Russia, and China here. If you'll notice, very familiar with this, back in the 60s and 70s, this was dominated. And this is, I cannot see my own thing in the way. These are, I believe, nuclear construction starts here. You can see how we dominated back in the 60s and 70s, but as the millennium has transitioned here, it's now dominated by Russia and most currently by China as well. We've got Vogtle being the only recent start down in Georgia back in 2013. If we look at grid connections, it's a similar picture. going back to the 70s and 80s, dominated by the US. Now that is completely flipped. It's dominated by Russia and China. The only grid connection we had was Watts Bar 2, but that project was actually construction start was back in 1973. For the century, for the 21st century, we've had 155 reactors total connected to the grid or under construction globally, and 105 of those are associated with China or Russia. A little more direct trend line here with China. If we, here this blue line represents what nuclear power has done for the US since 1969. If we allow the current fleet to just simply live out its natural 60-year lifespan, and that of course is doesn't account for early nuclear closures like we've been experiencing over the recent years, and some are still planned to close prematurely. But if we just let them live their 60-year lifespan, what you'll see here, of course, is somewhere around just before 2030, we start seeing a decline in nuclear output. A couple of points here: we not only really don't have a plan for how to backfill that much reliable baseload zero carbon power generation. Perhaps the more concerning part here are the national security implications of China going in one direction for one of the most critical energy technologies on earth, while the US goes in an opposite direction. So this asymmetry where China is growing in its nuclear expertise and the US is in decline constitutes what is clearly, if we go back to the early days of US nuclear power policy, where we proposed that we would be dominant in this policy. This is clearly a national security concern. So what we see here is the difference in contrast in perspectives here. While energy and nuclear in particular in the US is largely a market commodity or a climate issue, in China and Russia, they're instruments of national power to achieve geopolitical objectives. These are at the center of China's and Russia's energy policy. Very different than the perspective here in the US. So a couple of slides in closing. If the US, and again, we're orienting our energy policy towards diminished fossil fuels to reduce carbon emissions. If the US disengages from the global fossil fuel network and does not aggressively pursue nuclear power, a few comments here. Our geopolitical leverage and influence is going to be diminished. It's going to create openings for energy-rich and technology-advantaged countries, and I'm speaking here particularly of Russia and China, that's going to occupy space we once occupied ourselves, but there's going to be very different geopolitical objectives. The question there will be who's going to be the trusted energy partner for those emerging economies that we saw in the graph previously, particularly in the Asia-Pacific region, where GDP and energy demand is increasing. Secondly, here, the U.S. national security is going to be threatened if energy and the energy technologies that operationalize our industrial base, if they shift asymmetrically with Russia and China. That is, Russia and China are going in one direction, the U.S. is going in a different direction, and we become weaker in our industrial base. That is, our energy resources become diminished, our technologies that accompany those resources become diminished, less diverse, not as much flexibility, while Russia and China are expanding their energy resources and technology in their industrial base. So there's a very different there in the directions that our competitors are going compared with the direction that our policy has taken us. And if nuclear is not in that policy, it's going to be a serious consequence for America. So a question there would be, will leaders in China and Russia subject their respective industrial bases to an all-in effort to reduce carbon emissions? And I'll kind of push through it. So summary points: the space between where we are and where we want to be, we need to keep in mind is going to be dominated by great power competition. And so much of that's going to be indifferent to climate change. It needs to be navigated strategically. We need to think beyond just domestic carbon reductions and we need to account for these geopolitical implications of not engaging, particularly in the nuclear field. If we transition away from both fossil fuels, it'll dilute the diversity of our resources and technologies. This raises concerns as the emerging economies will be moving in the same direction as our authoritarian rivals. This is going to shift the geopolitical advantage globally in energy and energy technology partnerships. So I'm going to close right there, kind of push through those last few slides, and I'll stop sharing, and hopefully I didn't burn too much time there, Mariana, with fumbling around with that slide.
Oh, it's just great. You're cutting out a little bit, but I think it's your microphone. But you're very good. Very depressing though. I have to ask you one question, Dr. Gaddy.
Yes.
What are some of our promising, let's give it a little upbeat here.
Okay.
What are the promising nuclear technologies that you think can help realize this national security objectives or advantages?
Well, I think the recent announcement that we saw in Wyoming is encouraging. I liked the key thing about that one that I liked is that it's an advanced reactor, fast breeder molten salt reactor out there that's coming that they're looking at develop in Wyoming. I was very encouraged by that. I'm glad to see that of course we've got the NuScale light water reactor, but I was really encouraged that they're looking at some aggressive technology developments through that fast breeder reactor. I'd also add that I think what we ought to be looking at too, Marianne, is globally looking at working with a lot of our allies. And I do hear lots of conversation about U.S. industry reaching out, working with our allies across the world, particularly in the UK right now, to maybe get some semblance of, some gain in economy there and sharing the risk as we try and get these technologies deployed not only domestically, but also globally.
Great. I'm going to move quickly to Mr. Swilly.
Yes. Can you hear me okay?
Yes, sir.
All right. Well, thank you, Commissioners O'Donnell and Holden, for the opportunity to briefly chat this afternoon. And I guess just say next slide, Jasmine. Is that going to work? All right. Thank you. I'm going to probably start with a little disclaimer. I appreciate following David because he probably said some things that I can't say as EPRI, but we were established in 1972 as an independent scientific and nonprofit organization. So I will not get into advocacy type discussions, but I'll just talk about the facts. So I think our presentations will fit well together. And hopefully, Commissioner Holden, I'll be a little more upbeat, hopefully, in some of the work that we're doing to keep nuclear power operating. But EPRI is evolving along with the rest of hold on, Jasmine. EPRI is evolving along with the rest of the energy sector. A lot of things changing very fast, but our mission is to advance safe, reliable, affordable, and clean energy for society through global collaboration, science and technology, innovation, and applied research. I think this places the advanced nuclear technologies that are key both to sustaining the current fleet as well as improving the existing fleet and new deployment, puts it right in our sweet spot. Next slide, Jasmine. So kind of to set the stage a little bit, we need to triple the rate of energy-related CO2 reduction to achieve some of the targets set by the Biden administration by 2030. I think we can all see, there's on the slide there's the different sectors of CO2 production. We're talking about the energy sector. And if we're going to meet those 2030 targets and 2050 targets, it's going to take a balanced mix of energy sources. It's going to be a lot of renewables, but you can't get there with just renewables. And I'll talk a little bit about that later. In my opinion, you do need nuclear to be a piece of that pie. On the slide there, you can see the broad green from 2035 to 2050. It's really trying to recognize there are a lot of choices in front of us on whether we operate the current fleet to the end of life, if we shut units down early, if we extend the life of units, and then hopefully we are going to deploy SMRs and advanced reactors, as David just mentioned. Next slide, Justin. So if you think about some of the objectives that the industry, the nuclear industry is currently focusing on, you can really kind of boil it down to 3 areas. Advancing existing and new technologies. A lot of this is really where EPRI's work comes into play. Reimagining plant flexibility. By that, it's like, things like hydrogen production, desalination, energy storage. A lot of energy in that market right now. And then finally, deploying advanced reactors. So as we all work together to meet the decarbonization goals, and as new technologies are deployed for advanced reactor builds, operation of the current fleet will serve really as the bridge to the future. And we can't get to that future advanced reactor state if we don't keep operating the current fleet. Things like supply chain, competencies, personnel, workforce. So we must ensure continued operation of these existing plants and extend license life where applicable. So for my remarks today, I'm really going to focus on the work that we're doing to try to ensure that the existing fleet can operate as safely and efficiently as possible, while continuing to extract maximum value from these carbon-free generation assets. Next slide. But just some statistics to kind of keep us grounded. The impact of and these are US, some of these are world stats, some are US stats, but in the US, if you look at the power generated by the US nuclear fleet, the equivalent of avoided emissions from 100 million passenger cars. Pretty large. The existing fleet, 86 of the 93 reactors have been granted license renewals to extend their life from 40 to 60 years. The original license life of a nuclear reactor in the US was 40 years. We've also got 6 reactors that have been extended out to 80 years, with several others in the planning stages. So keeping the existing nuclear power plants operating for the long term greatly contributes to the decarbonization effort, also maintains jobs and tax revenue to be that bridge to tomorrow as we wait for advanced reactor build activity to ramp up. EPRI developed the technical bases and the guidance to inform the plant license extensions for long-term operations out to 80 years. The work we did really gave the utilities the confidence that they could make that leap. And extending the life of existing units, we've proven now it's feasible and offers a low-risk option for carbon-free power as opposed to building new resources. If modernization and improvements can be made to lower the cost of long-term operations, this option becomes even more appealing. Next slide. So plant modernization is a term and a body of work at EPRI that we use to describe how technology transformation applied in other industries can be used to improve efficiency of nuclear power plants. The existing nuclear power plant fleet was really designed and constructed mainly in the late 60s, 1970s, some in the early 80s. They're very robust, they work very well, but they haven't really taken advantage of a lot of the new technologies that other industries have. So this body of work that we put together really is putting together a set of criteria and methods that can help a utility determine if a plant modernization is feasible for them. And if so, help them develop the optimal strategy to achieving lower cost operating through modernization activities. We see many nuclear utilities using these tools today to identify and develop strategies and business cases. The technical areas we're talking about here are things like digital upgrades, wireless connectivity along with electromagnetic compatibility, software application integration using a common information model, business process automation, condition-based maintenance, monitoring for equipment reliability, automated chemistry monitoring, physical security, emergency planning, radiation monitoring, and structural health monitoring. I'd like to just talk about a couple of business cases that we've been working on. One is around digital upgrades. We conducted a cost-benefit analysis of implementing a digital upgrade to replace an analog safety-related I&C system in a light water reactor environment. Through this business case, we concluded that there are approximately $4.5 million of direct annual benefits can be realized in addition to an estimated $7.2 million in avoided material escalation benefits over the remaining life. You extended the life an additional 20 years to go out to 80 years. Net present value then increases from somewhere to $50 to $80 million range And this is just an example for one plant. If you escalate that across the entire fleet, you can see it's tremendous dollar savings. In another business case, we demonstrated the financial feasibility of implementing online monitoring and diagnostic programs, or M&D centers, that assess the value of avoided outages and preventative maintenance. We have a number of other business cases, and they are all available on our plant modernization toolbox at epri.com, and that is in a public-facing version of our website. Another topic around modernization is cybersecurity. It's a high interest across many industries today. And at EPRI in Charlotte, we maintain an I&C lab where we can investigate new applications, conduct training, do real-world simulations of digital systems, cybersecurity, monitoring, and data analytics. Lab features a process fluid flow loop that connects transmitters, actuators, and heaters to network security devices, cyber analysis tools, and a nuclear plant simulator. Next slide. I mentioned earlier about reimagining operations, and integration of renewables, you know, it will require a change in how baseload generation operates. You know, as more and more renewables come online, you know, the sun shines in the daytime, the wind typically blows in the late afternoon or evening, but you still need generation capacity for off hours. I would contend that nuclear power can be that carbon-free generation source. Some plants in the U.S. are flexibly operating today. Worldwide, you know, France, for example, they do a lot of flexing. But EPRI's been gathering those lessons and operating experience, as well as doing research to understand the impact on plant assets. I would say that flexibility and economics go hand in hand. Next slide. So as we look to the future, you know, as we do our research, we're really focusing a lot on more digitized plant design, maintenance, operations, both in existing fleet and the new build environments. These technologies include things like artificial intelligence, digital twins, data-driven decision-making, drones. On the topic of drones, one example of some work we did with a utility in the U.S., looking at their radiation safety program, we demonstrated and assessed autonomous drones, unmanned ground vehicle technology, and many different applications that were used to perform tasks remotely and without operator intervention that would normally expose workers to hazards and radiation exposure. There were positive cost benefits were found, including, you know, the elimination to do things like erect scaffolding to access elevated areas, reducing the number of personnel needed for routine operator rounds and surveys, and avoiding the need to down power to allow people to enter into areas like containment or the dry well. Next slide. And another significant opportunity that we're working on is around workforce training and development. We're placing a priority on accelerating the introduction and delivery of several training initiatives. We put a lot of work into developing what we're calling a common initial training program. But rather than having individual entities like utilities amend or maintain their own different training programs, we're developing a common program that we can share with our members who have existing fleets, updating their fleets, or even new entrants into the market. This approach offers the ability to tap into economies of scale across the entire nuclear industry. We're focusing in the U.S. first, but we see this as an opportunity to also be a global venture. Next slide. So I hope my brief remarks have stirred your interest in nuclear power as a piece to the carbon reduction puzzle. And I thank you for your time and attention and look forward to the Q&A.
Thank you, Steve. That was great and was more uplifting. So, Laurie.
Great, thank you. Okay, and my presentation is maybe a little bit in a different area. I'm going to be focused on voluntary markets for carbon-free and clean energy and the role of nuclear in them. These markets have existed for over 2 decades and have been driving a lot of renewable energy generation, and there's increased discussion of expanding that to carbon-free energy and trying to look at it on an hourly basis. So that's what I'm going to be speaking about. Next slide. So just to give you some history, these markets have been substantial, I think, in their ability to drive new clean energy capacity. Again, it's been focused on driving renewables specifically. In recent years, this slide is from Bloomberg New Energy Finance and just shows the graph, just shows the amount of large power purchase agreements for clean energy, for renewables in recent years. And you can see that growth over time. These markets are a little bit broader than just power purchase agreements and have been going on for 2 decades. So, but just to give you an idea of some of the growth, a couple of things I'll note about these markets: they've been focused largely on renewables, very heavily trying to drive new renewable capacity on the grid and trying to drive low types of clean energy with low environmental impact. So usually they align, many of the programs that guide corporate or city action in this space, have some restrictions on, utilizing low impact hydro, which is also done in state renewable portfolio standards, sometimes biomass, restrictions on biomass or other technologies. So just that's the history of these markets. I'll also say that WRI does a lot of work today with cities. We've historically worked a lot with corporates in these markets, but are doing a lot with cities. And, there are about 200 cities with 100% clean energy goals that are driving substantial amounts of renewables as well, more than 3 gigawatts last year. So it's not only corporate buyers, it's universities, cities, other institutional customers as well, and residential that have been driving clean energy through these markets over time. So next slide. But going forward, there's some realization, following on Stephen's comments that, the role of customers is going to change. We're trying to add a lot of renewable energy capacity in the next decade. You can see this slide features some data from the UC Berkeley 2035 report of the path to try to get to 90% clean energy by 2035. And then we've got the Princeton Net Zero America study that talks about, how do we move the power sector to net zero by 2050 and some of the things that we need to do to get there. A lot more renewables, a lot of transmission, large flexible loads, new nuclear, carbon capture to get there, right? So realization that we're trying to move the whole grid to carbon-free energy, and we need a lot of strategies to get us there. We're going to need a lot more flexibility, as Stephen was talking about, to get there. Customers can play a role in that as well. So next slide, we've got a new report that focuses on that, how can large energy buyers help with this grid transformation that's needed in the next decade or more, and trying to get us to 100% carbon-free electricity, and how might some of these things change a little bit from what these markets have traditionally done in the past and the role of customers in the past. So that's what we explore in this paper that just came out in late August. So next slide, the link is on the slide here. So we talk about the need for transformative procurements, for customers to take additional actions to help get us there, to be able to integrate all the renewables on the grid, enable others to bring clean energy on, maximizing environmental impact and emissions reductions, bringing on new renewables and clean energy capacity, enabling new technologies and innovation like storage technology, and maybe even carbon capture. Some companies have been making commitments in that space, and all the while really trying to, throughout all of this, enabling an equitable and just transition. And so through procurement approaches, trying to make sure that we're driving benefits for broader communities, disadvantaged communities, and creating sustainable jobs. Next slide. So, the report that we've written features a number of case studies of different entities, corporations or others who are taking some of these actions already. And there have been commitments by a couple of corporates and cities to try to look at hourly purchasing of clean energy. So the way markets work today is that company will say they, will determine they use, X number of megawatt hours in a year of energy, and then procure an amount of renewable energy equivalent to that. There's increasing recognition that we need to think about the timing of the generation of the clean energy, particularly if it's wind and solar. They don't operate every hour of the day. You get a lot of solar midday and wind in the afternoon or evening, as Stephen discussed earlier. So trying to recognize that customers can also play a role in helping to make that work on the grid and trying to use the clean energy when it is available. So Google has been a leader in this and announced their commitment to trying to procure 24/7 carbon-free energy. So for every hour of the year, they're trying, and every hour of the day and every hour of the year, trying to buy carbon-free energy. Microsoft has a new commitment like that too, and so does Des Moines, Iowa. And they're taking, some of these entities are taking a broader approach of using carbon-free energy, so not just renewables, but other technologies as well that are on the grid that are carbon-free, including nuclear. So for these kinds of commitments. So that is discussed in our paper. Next slide. And we kind of broke it down, the steps that we think companies and cities and other entities can take to get there, to try to focus more on the how and when they're using clean energy. It involves a number of things to get there, is trying to match the timing of the purchase of clean energy with the consumption. And ways to address that are, a customer can do that by trying to also look at their demand side and how they might even shift their loads to match up with clean energy. So they can try to purchase it to match their load, or they can try to also shift their loads. EV charging is an example of that. There's a lot of other things as well where customers might be able to use energy at different times to enable more clean energy on the grid. And there's some interesting examples of that in the report. Another approach is really to think about driving more firm dispatchable clean energy technologies to get there, right? I mean, this whole issue of we're going to need a power 24/7. How do we do that? It's, many studies have shown that it's cheaper if we've got some dispatchable resources on the grid. Stephen was talking extensively about how they were thinking about trying to make nuclear more flexible to be able to accommodate more variable renewable generation on the grid. So this is a piece of it as well, and companies and cities may be able to play a role in that as well. And then just a few other things I've mentioned, storage and other decarbonization technologies, customers can play a big role in driving that, and thinking through as they're making all these decisions about the portfolio that they're procuring, figuring out ways to operate those resources to maximize emissions reductions, and incorporating equity throughout all of their procurement practices, workforce investments, driving jobs, trying to drive benefits to local communities that can benefit from clean energy sources. So we talk about all of that in this report and approaches we can go forward. There's some links to the report in the chat. So I kind of spoke a little bit about this. I'm not going to go into detail on it, but just to, if it wasn't clear, just to kind of give a little bit more color to the first things that I noted in the last slide. This idea of hourly purchasing, it's really, there's efforts by Google and Microsoft to really try to figure out contracts that they can sign to make sure that the clean energy is delivered and aligns to their load on an hourly basis throughout the year. So we have seen some, Google just signed a contract and announced an agreement with AES recently to do this, and has actually done procurement for a large portion of their load on an hourly basis. And Microsoft has some interesting deals in Europe as well in this space, and is committed to doing this. On the load shifting side, there's a lot of different ways of doing this. It can be demand response, electric vehicle charging, shifting loads across locations. Google's done some of that with their data centers and things like that. So next slide. And then this question of using new dispatchable clean energy, this gets into this discussion of nuclear, I think. And, you know, Google in particular has been, you know, calls for utilizing nuclear. They do utilize nuclear on the grid to meet their 24/7 commitments. There are other buyers who also support that. There is not consensus, I think, across all buyers or the marketplace to do this outside 24/7 commitments, but it is being included because of trying to purchase on an hourly basis, including all of the carbon-free energy on the grid, is a strategy that some buyers are taking to do that. It's also possible to do this with other firm types of renewable generation as well, including potentially hydro or geothermal, which is also being done. And then I'll just say, you know, briefly, storage certainly plays a role in all of this, and electrification. I'm not going to go into that too much here because we're focused on nuclear today. So let's go to the next slide. So I started to talk a little bit about this, but this is really the crux of, I think, what is of interest in this particular webinar is what's the role of nuclear in these markets? What's the potential for it? And I'll just say, I've made some comments about how these markets have been designed historically to drive renewables, and they're aligned largely with eligible renewable definitions that have been used historically in state RPS policies and things like that. So usually many of the programs that support these kinds of voluntary purchase markets have focused on driving new renewables on the grid with customer demand. So, and now we're starting to have more discussion about, we're trying to get to 100% carbon-free electricity on the grid. So what does that mean in these markets? As I said, some buyers are supporting the use of nuclear and potentially even fossil with carbon capture for 24/7 purchasing goals, with the realization that we need to operate the grid going forward on a 24/7 basis on carbon-free energy, and that these technologies will likely play a role. But this is not widely supported or universally supported by buyers who are, you know, still making 100%. Many of them have established 100% renewable energy goals and continue to do that. Often it's those who've already achieved 100% renewable goal who are really trying to do these hourly matching kinds of activities. So, and I think, you know, key considerations of the role of nuclear in this going forward is this discussion, right? And that there are, you know, a number of buyers who have come out in support of this, of using nuclear in these markets. But there's always been, I think, a real heavy focus on ensuring that what these customers are doing in these markets is additional to what's being driven by policy, and that they're driving new capacity on the grid. I think one of the questions that comes up with nuclear is, well, we're seeing plants close, right? Can you save the plants? And that's a challenging determination to make. And I think a question of whether these markets could really play a legitimate role in, because of the dollars and the uncertainty potentially of kinds of transactions in this market, you know, unless they're really long-term and really major, could they really play a role in ensuring the extension of the life of a nuclear plant, or is that really the role of policy? I think it's a key question, right? And we have seen states already taking action to provide incentives to nuclear to maintain those facilities, and there are a number of provisions in both the bipartisan infrastructure bill as well as the reconciliation bill that also have incentives for nuclear to try to address that. So I think it's a key question of how much do these markets have, you know, play a role in this versus state and federal policy in trying to maintain nuclear on the grid. I think the other thing to think about too, I mentioned earlier that, you know, these markets have traditionally, because they're voluntary markets, the cities and customers are participating in them, and they want to avoid criticism. They're being driven by sustainability. There's a heavy emphasis on low environmental impact. So there have been restrictions in the past on eligible technologies, like including low impact hydro, certain types of biomass technologies with fewer emissions or fewer environmental impacts and so forth. So that's another issue on the nuclear side with some of the considerations around nuclear waste and safety issues and things like that. So these are open questions, I think, and there is more discussion of this and some interest in utilizing nuclear on the part of a number of buyers in these 24/7 hourly purchasing goals. So next slide, which I think is my last one. So, the path forward, I think there is a lot of recognition that we need to move grids to 100% carbon-free energy. We do need dispatchable resources on the grid to be able to get us there, or at least that, the studies show that it is cheaper to do that, to have some mix of resources on there. And the question, one of the things I think about these markets and these hourly 24/7 products is that there's not a lot of products available on the market for people to be able to make these purchases. I think there's interest on the part of utilities and others thinking through how they could provide these kinds of offerings to customers. Google's made a lot of progress and some others as well in trying to do hourly procurement of clean energy. But it's, a lot easier to do that in a competitive market as opposed to a vertically integrated, traditionally regulated utility market, unless the utility is offering a product there, right? So, and then the other key question here, I think, is that the frameworks, the programs that have been established, I mentioned how the structure of those programs and their eligibility and so forth, and there would be need to evolve those kinds of programs and practices to broadly incorporate other technologies such as nuclear. Hopefully that was a helpful overview of the state of these markets. Thanks very much, and I'm happy to answer any questions.
Lori, one thing that's shown up in the chat consistently, people would like to know, what are the types of buyers that have expressed support for the use of nuclear, meaning those 24/7 purchasing goals?
Yeah, there is a letter. Google has been a leader really on this, and there's a letter that is cited in our paper that lists about 15 different entities that support these kinds of goals. I can pull it up to try to be accurate in terms of listing them, but it is documented in that paper that I just mentioned.
That's great. And I think that we have a link in the chat if people want to get a copy of this report. I know I'm looking forward to reading it myself. I would like to ask all the panelists, if we could, what do you think state and federal policymakers should know as they consider policy options, whether to compensate or incentivize clean, firm power?
What should they know? Steve, do you want to take that, or you want me to take it? I think a couple of things. One, that, if you look at many of the studies that show where do we need to go in the power sector, we need to add a lot of renewables in the next decade, but we may not want to have all renewables right on the grid because it can be cheaper to have firm dispatchable energy sources. And that's a really important element of getting there, and thinking through ways of maintaining nuclear on the grid safely, but ensuring that it is going to operate safely for the lifetime that it has, and bringing other firm dispatchable technologies on the grid is really important to have that diversity.
I'll make a comment, Marianne. I think one of the things that would be helpful for them to know, or at least understand, is, and we talk about energy diversity almost to the point where it's cliche, but for policymakers to understand that there are operational characteristics across those resources and technologies, understanding things like capacity factors, also understanding things like, even if you have solar and wind, does not necessarily translate to diversity, since oftentimes those resources are available out of sync. So, understanding that diversity and callability and dispatchability and flexibility are characteristics that they should understand rather than just the resources being different. So I think there's a lot of operational characteristic, functional features of the resources and technologies that they really should educate themselves on. But because as we narrow our resource base, we're getting into some deep water.
Are we missing any stakeholders that should be part of this process too?
If I could amplify what David just said before we get into stakeholders, I think there needs to be a value in what baseload generation like nuclear, 24/7, always operates. You need things like inertia of the grid. You know, if I had a grid that had nothing but wind and solar, and that's the flexible nature of how that operates, I need to have spinning reserve to come on and, you know, keep the lights on when the wind doesn't, you know, blow or the sun doesn't shine. And if I'm going to have that spinning reserve to pull up, you know, do you want it to be gas? Do you want it to be coal? Do you want it to be carbon-free nuclear? So I think there's a value in that piece of the market of what am I going to bring in to keep the lights on when my renewables aren't operating.
To me,
I guess
that's where
also have.
I'm sorry. Nope.
No, go ahead.
No, I was only going to say that's to me where levelized cost of electricity has got some shortcomings. It does not, to Steve's point, it doesn't reach out there and account for some of the intrinsic value of these resources and technologies, which is part of what I was pointing to in my talk, is the intrinsic value that doesn't isn't reflected in the market.
I'm also seeing that, you know, if you have a large solar field that you're trying to, well, the capacity is one thing, the amount of energy that it puts out is another factor, and you try to find equal energy that's put out, say, by a coal plant or a gas-fired plant, you can probably more easily cite something that is closer to the load. Particularly in a state like New Jersey, we don't have all that much room for a lot of solar out there. There is some utility scale, and we try to use, you know, inefficient soils for putting these fields out, but they're not necessarily where the load is. So you want to talk a little bit about how nuclear of the future might fill in some of these gaps in producing clean power.
Yeah, I'll take a shot at that first. I think what you're describing is a combination of energy density, which is very important. You know, I can cite a 2-unit nuclear plant near a large city and pretty much provide all the electricity needed, as opposed to, and I'm not saying wind and solar is bad, but the amount of square acreage that you would have to take up to replace that energy density is pretty large. And those are large plants, but I think the other part of your conversation is, what about remote areas, you know, isolated grids, Alaska, military bases? You know, small modular reactors, I think, are going to be a great tool in the future to provide the right amount of power for a closed loop, as opposed to being part of the major grid. And that's there should be some value in that flexibility.
And there's also coming down, and Steve, you can correct me on this one too, but even below small modulars, we've got micro reactors somewhere in the future too that we're talking about, where we can, and I'm not going to refer to these as distributed technologies, but they are certainly getting to the point where we can distribute these reactor technologies out and create some islanding capabilities so that we can keep that grid to where we can cut off certain sections if we've got security issues or downtime or whatever. But I think those small modulars and those micro reactors are going to give us a lot of flexibility down the road, Mariana, to reach some of those rural areas in particular. And I know that the cooperative family out there, which serves a large number of our community, they are looking for those kinds of resources themselves. And one last thing that often is not thought about when you talk, Steve referenced it as the energy density. And Mariana, you talk about it too in terms of capacity. Capacity is a really bad comparative here. We've got to look at generation. And if you look at it on a generation output, and again, it is not to belittle any renewable. We need as many of these resources as possible. But the lifespan, when you look at a lifespan of a solar farm or wind farm and the footprint that it takes up, when you start rotating those utility scale technologies out, somehow you've got to either have an equal land space out there when you start to replace it, or you've got to tear the whole thing down and you've lost all the asset. And you're going to do that a couple of times during the lifespan of a nuclear reactor. So there are lots of things there that, as far as lifespan goes, I think that policymakers need to take into account too.
Great, thank you. And all three panelists, thank you very much. It really is a great look at renewable products and good, clean energy. And again, I refer everyone to the connection of to the report that Lori Bird cited. And I'll turn it back to our leader, Tony O'Donnell.
Thank you, Mariana, for doing that. And thank you, Dr. Gaddy, Steve Swilley, and Lori Bird for their time in making these presentations to our members, and the DOE Office of Nuclear Energy for supporting this webinar. We look forward to seeing all of our members during the NARUC annual meeting from November 7th to the 10th, 2021 in Louisville, Kentucky. NARUC's coordinating a general session. I'm excited about this. On November 9th, on a coal to nuclear transition opportunity, focusing on the announcement in June of 2021 that TerraPower would be locating an advanced nuclear reactor, as was mentioned earlier, on a retiring coal generation site in Wyoming. We look forward to welcoming Dr. Catherine Huff, Principal Deputy Assistant Secretary for Nuclear Energy at DOE, and other expert panelists for an exciting conversation with NARUC President Paul Shalander. The meeting is hybrid, so you'll be able to view that session virtually if you decide not to attend in person. Of course, we hope to see you, but the exciting thing about this development for me is, and having recently participated in a multi-state transmission project and the difficulties therein, you use the existing transmission infrastructure. You replace one generation technology with another, but you'll avoid most, if not all, of the discussions about whether or not you got to site new transmission to bring this on. And so to me, that's a very exciting aspect, and I hope you'll tune in for that if you can't be there in person. Our next quarterly partnership meeting will be on December 10th from 2 to 3 p.m. Eastern Time. And check NARUC's website for information on other upcoming activities, and please reach out to Kira Zittelman or Jasmine McAdams at NARUC with any questions or feedback. Thank you today for attending, and have a great weekend.
Thank you all. Thanks for having us.
Thank you.
Thank you.